Hi, my name's Alistair Blachford and I'm the Bioscience Computing Manager. And since 1985, I've been working here. I've been paid to help a whole bunch of really smart people figure out how the living world works. How good is that? I came to UBC in the fall of 1980 to do a master's with Carl Walters. And I thought UBC was the coolest place ever because we had an apple orchard. We had about 6 or 8 of these spread around the periphery of the Ralph York room. So it's on these that we did all the simulation assignments and everything for Carl's courses. And later on, when I joined the staff of the computing unit, it was called something different back then, all our computing was done on a great big machine called the VAX 11750, and our interface with that was just dumb terminals that would send characters back and forth from the machine. Everybody used the one machine. And then the architecture changed so that people could have more computer power on their desk. The PC revolution. The IBM PCs came along, and the Apple Macintosh came along, which put a ton of power on a desk. So all of a sudden people could be master of their very own computer power, and the way we had to architect the system that the researchers used changed. We changed from central machine to client server. So I, as manager, got us through that transition. So Don Ludwig contributed a Sun workstation, which again was meant as a desktop thing, but it's a very powerful one. And I did a little presentation at a faculty meeting, and I said, we got to switch architectures because this VAX thing's going to go extinct and it's too expensive. And a bunch of faculty members chipped in PCs to be clients, and we basically set up the first grad lab type thing. So Judy Myers and Jamie Smith threw in machines that we called Bug and Bird, and we had the other machine as a server. That was our transition to client server, the way things are now mostly. And computing power just keeps escalating at a mind-boggling rate, as I think I can show with the little computer museum. And as the computing power increased, the kinds of questions that could be asked changed also. The cute little questions remained, but you could ask really big questions, do meta-analyses, use big data, and do all the genomics stuff. So the genomics stuff is very compute intensive and RAM intensive. Like, I would never have imagined that we'd have multiple machines with 1.5 terabytes of RAM. And probably in a year or two that's going to seem small. But that's what you need to put together your genomics data. Most sequencing is still shattering the genome and then getting the computer to line everything up. That was unthinkable a bit over a decade ago, I'd say 15 years ago. So now, although we have all these massive computers on our desk compared to old times, we need even more massive central computers. So we're using both levels now, the desktop power and the central power in our departmental machine room. But we're moving much more into an era where we're going to be running everything in virtual machines. And we're going to need to do that for scientific research to kind of wrap up and containerize our work on each project. Right now, the problem is you can store your data, but if you ever want to use it 10 years down the road, all the software that you used it for has changed. So I think in the future, the zoology computing unit is going to offer a way to do your work on a particular project in a virtual machine that you can just tie up with a bow, data, software, everything, and park it and therefore achieve far better way to replicate results than we have with the way we do analyses right now. That's a future trend. And week by week the power is going to go up, and we're going to shake our head week after week, not believing what power comes along.